Hello, everybody. Welcome to the fifth lesson of Cycle 3. Today, we're going to be working with quadratic equations and solving them by factoring. So let me just go into presentation mode here. And I forgot to put the learning goal, but the learning goal is to be able to solve quadratic equations by factoring. So what does it mean to solve a quadratic equation? Well, you might know that we've been finding zeros. These are also called x-intercepts. They're also called roots, and they're also called solutions. So all we need to do is find our x's in an equation, and that tells us what our solutions are. And that is solving a quadratic equation. And the steps are this. If we're going to solve it by factoring, next lesson we're going to do it a different way. But to solve an equation by factoring, we need to rearrange the equation so that it equals zero. So everything needs to be on one side and zero needs to be on the other. Then the second part is to factor it if it's not already factored. And then the third step is to set each factor to zero and then solve for x. And then finally, the fourth step is, well, these are the solutions. So you're going to write, therefore, the solutions are these numbers for x. So we're going to do a few examples. So let's see. We have find the solutions of x squared plus x minus 12 equals 0. So this is an equation in standard form, right? It's ax squared plus bx plus c equals to 0. The nice thing here, we already have all of our terms on one side and zero on the other, so we don't have to rearrange. So we can just write it down again. The second step is to factor this. So to factor this, you need to find two numbers that multiply to give negative 12 and add to give positive 1. So that's positive 4 and negative 3. So we write this in our binomial form. Now I want you to notice here, for this equation to be true, so for this left side to equal 0, one or both of these binomials have to equal 0. That's why our solutions are called zeros. Because if I make this, find x that makes this 0, it will make this equation true, which is a solution to the equation. So that's why these are called zeros. That happens in a graph where it goes through the x-axis, so that's why they're also called x-intercepts, and that's why they're also called solutions, because they solve this equation where the left side is equal to 0. So what we're going to do, the next step, is to set each of our factors, so our binomials, equal to 0 and solve for x. So we're going to do this one first. So you're going to set x plus 4 is equal to 0. So basically this is saying, what does x have to be to make this factor 0 so that this equation becomes true? Well, obviously, if we rearrange this, x will be, I want that to go away. X is equal to negative 4, because if I add negative 4 and positive 4, I get 0. So that's one of my roots, one of my solutions. So let's do the second one. X minus 3 equals to 0. And if you take this 3 to the other side, or you could think about, what does x have to be to get to make this equation 0. So I'm going to take that 3 to the other side. X has to equal 3 for this to be true. So therefore, my solutions to this equation are x equals 3 and negative 4. You can check this with Desmos. So if you put this equation into Desmos, you will see that the x-intercepts are indeed when x is 3 and negative 4. So that's why, again, these are called zeros because we're making each of these 0. They're called solutions because these are the solutions that make this equation true. And they're also called x-intercepts because that's where the parabola goes through the x-axis. I think that's pretty cool. So let's do a couple more examples. So example 2, find the solutions of 10 equals 7x minus x squared. So here we need to do a little bit of rearranging to get all the terms on one side and 0 on the other. So because this is a negative x squared and I don't want it to be negative, I'm going to take it over to the left side, which means I'm going to take my 7x to the left side as well. So if I rearrange this so all my terms are on one side, leaving me with 0 on the other side, this is what it looks like. So x squared minus 7x plus 10 equals 0. Okay. Step 2 is to factor it. So I need to find two numbers to multiply to give to 10 and add to give negative 7. So if we do that using whichever method you like, if you like doing the box method or whichever methods we've been doing in class, basically finding the two numbers, you get x minus 2 times x minus 5. Oh, man, I hope Okay. Um, so now step 3 is to set each factor equal to 0 and find x. So we're going to set x minus 2 is equal to 0. So x has to be 2. So that's one of our zeros or solutions. And the other one is x minus 5 equals to 0. So x has to be equal to 5 as well. So therefore, the two solutions to this equation are 2 and 5. Now I want you to know sometimes you won't get any solutions. Sometimes you could just get one solution. Because remember, if we look at a parabola, and we can check this one with Desmos first, there's our two x-intercepts, so they match our answers. But remember, if the parabola is just sitting on, just touching the axis, we can just get one solution. Or if it's above it or below it and going down, you would get 0 solutions. So just want you to know you could have 0, 1, or 2 solutions for these equations. Okay, let's look at the third example. This one's going to be a little more involved when we factor. So we have two of our terms on the left side. We're just wanting to get this negative 6 on the left side so that we can have 0 on the right. So let's rearrange this. So the 6 is now a positive 6 on the left side. Now we're going to factor this. Remember to look for a greatest common factor that you can take out of each term. So you could take a 2 out of each of these terms, which means this becomes negative 2x squared, this becomes x, and this becomes 3. And now you have a somewhat simpler equation to factor. So if we factor this, remember, when you have a number in front of the x squared, you now have to find two numbers that multiply to give a times c, right? So negative 2 times 3 is negative 6. So two numbers that multiply to give negative 6 and add to give positive 1. And if you do this whichever way that you've been liking, either doing decomposition or doing the area model with the box. You should find that it becomes negative 2x plus 3 times x plus 1. Okay, so now we are going to set each of our binomials to 0 and find x. So if we have negative 2x plus 3 equals 0, we have to take the 3 to the other side and then divide by negative 2. So we get x equals 3 divided by 2. And then our other one's a little easier. X plus 1 equals 0. So x has to equal negative 1. So therefore, our solutions are 3 halves, or 1 1/2, and negative 1. And if we graph that in Desmos, you will see those are our solutions here. Good. So here's some practice for you. If you want to pause the video right now and try these, and then on the next slide, the solutions are posted. So pause it here, try these out, see if you can come up with solutions, and then restart the video. Okay, so here are the solutions to those. This one you didn't have to do much to. All you had to do was sit. You didn't have to do the first two steps. You just had to set these equal to 0 and then find your x values. Here, um, you had to factor a little bit, but if you take out a 3, you get 3 times x squared minus 4, and x squared minus 4 can be factored into x plus 2 times x minus 2. And this would be similar, sorry, if you take out a 2, I guess, you get 4 and 9, and that's a difference of squares. So your factors will become negative 3 halves and 3 halves. And then this one, you had to do all 4 steps. You had to rearrange and then take out, oh no, I don't think you could take out a factor, but factor it and you would find there was only one solution. And if you want to check those in Desmos, you can, right? If you graph these equations, you would be able to find those solutions as well. Okay, so additional you try. Go ahead and do day E8 of the Cycle 3 practice booklet. There's a lot of questions on there. The answers are provided. Please do that till you feel comfortable, and then you can try the 3.5 quiz on Brightspace. All right, please let me know if you have any questions. You can contact me using the envelope in the upper right-hand corner of Brightspace, and I'm happy to help. All right, that's it for today. And next time I will show you a different way to solve these equations, which I think you'll really like. All right, see you next time. Bye-bye.